All right. Good afternoon, everyone. This is Amit Tyagi. I'm AVP with Infinite Computer Solutions and leading the telecom and media practice. Today, I'm here to talk about testing heterogeneous artificial intelligence and machine learning models. Let's look at what we are trying to do here. And we are trying to scale from doing to what should be done in the world of intelligence. What does it mean? It means that whatever we are doing, that only suffices the current needs and the operations and practices within the testing stream. What should be done is exactly applied science, intelligence, which can give you more edge over the regular testing operations. If I have to give you just some stats, by 2025, the AI market will surpass about $100 million, US million dollars. And all these investments which are being made, they are being made to use the human intelligence, machine efficiency, and to optimize the business problems. What all can AI solve? It can help you with a lot of intelligent prediction, forecasting for the exact practical business problems which you face on a day-to-day basis. What I'm trying to focus in this particular paper is we are going to adopt some simple solutions of problems which can help us in test automation, which can help you in self-learning and make decisions about a lot of your testing problems in real life. This will give you some advantage on the regular cognitive automation. And we will also focus on how we can thoroughly test some of these models which we create in the AI world and how we can put together into a simple approach and the ecosystem around the heterogeneous AI models. So let's look at the overall world of AI models, and then we will get into some more details about it. So if you look at, I'm looking at the HFS research, which was done in 2019. And what it says is that RPA is a continuum and RPA as a gateway. So all our automation begins with RPA. In this particular example, where we are trying to show the data center automation, where some of the examples from runbooks, scripting, scheduling, etc. we are taking. And there are certain tool sets which we are being using here. The next step on top of this is the cognitive computing, which we put in, and then the artificial intelligence. This is where most of the practices in terms of intelligence come into play. Now, what we are looking at is you have the structured data, you have the unstructured pattern, and you have the unstructured without patterns. Now, all of these problems are addressed by a lot of AI models and a lot of artificial intelligence. And we are going to see how we can take care of all of this rule-based, standardized, and dynamic languages, and how we can apply testing on top of it. So let's look at some of the models in testing world. What happens here? You have certain type of models. You have supervised models in which we deal with classification problems, regression problems, where we have to predict the binary or multi-class discrete outcomes, or we have to predict a numerical value. We also have unsupervised, where we deal with neural clustering, association, and dimension related problems. Either we are recognizing some sort of cognitive pattern, either we are figuring out a group, we are trying to associate some patterns from data, or we are trying to generalize relevant information out of our data. And then your imitation-based learning models, wherein you are performing certain tasks without training the data. Now, what happens in this whole equation? When we look at the AI/ML models, right? Because this whole discussion we are talking here is all about data center, data science testers' life. If you look at what a data science tester has to deal with on a day-to-day basis, if a person has to test certain data science model, he has to look at the machine learning algorithms which are being used for that model. He has to get familiar with a lot of IDEs which are being used. He has to check the deployment models, whether you're following AWS or Azure-based, or you have your own platform which you're building. You have to look at certain scraping methods, a lot of mathematics and statistical understanding. You also need to have a fair understanding about visualization tools and how the whole analytics and visualization has been done, and the overall analytics in terms of feature data wrangling and other EDAs. Now, when I come across real life models which we deal with, we look at certain data sources from where your streaming actions happen, your operational systems. It could be distributed and centralized monolithic systems, databases, from where you are reading all the information. You can also have certain documents, images, feeds, videos, logs, etc., which can be input to your system. This is where the next step comes into play, where you have to organize a lot of your processing. Now you can fetch all this information through APIs, and this is where your ingestion happens. You start doing all sort of transformation, normalization, cleaning, processing, etc. You do all your ETL operations. Once your data is cleaned up, you start your modeling. You create the clustering algorithm, learning algorithm, put together the whole model in place. If you are using certain warehouses, you will connect with them. Otherwise, this is where your whole data model creation is complete. Then you go into certain applications and certain stages where you have to analyze and execute this whole experiment. The example I've taken here is a financial example, and all sort of experiments and tests what we are performing here, they also need to be tuned in. All those models which we are creating, we need to make sure that these are in line with the requirements, certain versions which are required, the analytics capabilities which you are looking at from optimization, forecasting, reporting, discovery, and prediction, etc. All of those need to be in place. And then finally, we have to deliver these models on certain platforms where they can come into play and help into consumer detection and the model outcome. What happens in this whole flow? Why was I actually trying to show you? If I have a simple model, it's easier to do. But I'm dealing here with heterogeneous models. What it means is, in this example, I'm trying to show you that if you have a heterogeneous example where you have multiple different models and they are trying to solve certain business problems, this is how this situation becomes complex. You have certain channels, you have a large number of algorithms, you have certain patterns which you have to deal with. You also have to deal with large volumes of data sources. You have to deal with multiple data models, which will be of different kinds. So what I'm saying is certain models will be of type A, type B, type C, etc. So they have certain different outcomes which you have to deal with. An outcome of a data model can be an input for a heterogeneous model, and then they can be integrated to certain applications to get you the desired outcome. And then you have to connect with best algorithms to get the best output, and then connect with APIs and all to get the best version out, and then finally deploy. So this is what we are dealing with here. In a tester's life, this is a very difficult equation. And if he has to deal with this large set of data, then this becomes a very big problem. What we are suggesting here is, we looked at the end-to-end flow for the AI model problem, and we tried to divide it into very simpler terms so that it's easier and it makes testers' life easy. Plus, it gives you the automation edge which is required in order to consume these and give you the desired outcome. So I'm gonna go in detail for each of them. I try to divide this into 4 different logical buckets. First one is the requirements. This is where all your use cases and stories which are draft, which could be in the form of data acceptance test, requirements acceptance test. Then you have the data layer, wherein you deal with the data sources, all those data sets which are being created and which are fed into your model data. This is where all my data validation tests are in place. The third stage is model layer. This is where my actual model comes into play. I do all my model configurations. There are certain different kind of models which I create because I have to make sure that the best model, which is giving me the best result and the best score, that's what I want to use for this particular business problem. This is where I perform all my model validation test. The fourth stage is deployment, wherein I have my staging environment where I do all sort of permutation combinations. Then I perform regression, performance tuning of my model. And this is where I do post-deployment validation test. So if you see, I divided this into 4 logical buckets, and I also tried to keep an execute train at the bottom. What it means is at each individual stage, I'm going to perform certain types of tests, which will help me segregating these logical buckets and transferring of the responsibilities from one stage to another. So at the stage of requirements, I would be focusing on use case functional validation, stories functional validation, data source checks, validation, all sort of activities. When it comes to data layer, that's where I get into data source, data validation, data sample test, etc. I also look at my model sample test, model data inputs, automated suits here, and what are the training sets which are required. Then when I with my model layer, this is where I do all my model training, E/B, if you're dealing with experiences, all sort of configurations, all sort of selection, verifications which you're performing. If this is interacting with certain services and APIs, this is where I perform my services testing. Then finally, when it comes to deployment, that's where I perform all my smoke and sanities, all my DevOps when it goes to that pipeline. I check all my deployment configurations, deployment test, and all my environment checks. And then finally, it goes to the performance testing stage. So if you see, this is very logical step. If I divide this whole thing into this equation, it makes this whole task easy. And then there are certain tools at the bottom which I can consume in order to automate certain responsibilities. Now let's look at how I can apply the digital workforce here, which can be in the form of certain RPA components or in the form of AI models, which I can also apply on top of my testing problems. Again, this is a 4-step process: discover, capture, automate, and optimize. I would be discovering the processes in an automated manner wherever possible. I would be looking at the data understanding, which could be in the form of unstructured data, intelligent data, and any predictions which I have to do from a data standpoint. Now, when it comes to the AI and RPA application automation, this is where I can have my bots do certain testing tasks, which can help me to give me efficiency. Otherwise, I can have my intelligent AI models as well, which can work in attended and unattended fashion and can give me the best ROI here. And finally, the optimized stage, where I look at the operational insights on the testing side, and I look at the business insights, which can be value driven. And then these things can help me figure out where am I standing and how I am interacting. So let's look at the first layer, data testing. Now, this is where most of my data testing comes into play. And I am trying to look at all my data sources. And at the top, if you see, there are certain channels which I'm dealing with. This is where all my interaction is happening from human to human, human to machine, and machine to machine. And what I would be doing at this layer, my focus would be on metadata testing, data completeness, data quality, transformation, subsets, all regression, incremental data, etc. And I would be segregating to this layer so that I'm focused. I know what I'm doing here. And a lot of these tasks which I'm performing here, I'll give it to my bots and certain models which can automate this task. So this will reduce some of the this will offload some of the operational inefficiencies which I have in the system. And I would be focusing on areas which are useful and which can give me the value. When it goes to the next stage, right, this is where I start looking at how am I going to do testing for my AI/ML model. Now, on my left-hand side of the screen, I have all the heterogeneous models, which are of different types. If you see, I've depicted 4 different types of models. Model 1 is of type 1, model 2 is of type 1, model 3 is a type 2 model, and model 4 is a combination of type 1 and 2. So I'm similarly dealing with certain different type of heterogeneous models. What I would be doing in the temporary store where I'm doing my model planning, this is where I would be training my model and doing the testing of my model. So I'll keep it very focused on that particular activity, that all my data sets which are being pumped into this model, all those equations and algorithm which I'm consuming for my model, I would be training and testing. So this is the stage where my whole model planning, testing, and validation happens. When the development is happening and the whole equation is going on, that's where I do a lot of model quality verification checks from a data relationship standpoint, algorithm validation, whatever data scientist is using, all the API middleware communication rules, historical checks, prescriptive checks, based on the business requirements, all those model analytics which are required from a score comparison and effectiveness. And then finally, at the visualization stage, wherein I would be looking at the insights out of my model. This is where I would be focusing on A/B testing from an experience standpoint. What are the different type of experiences we are offering to consumers, end-to-end, any mocking required because these models are not in production yet, any defect forensic which are required beforehand. And this is where I will apply a lot of my AI automation using AI models. Release prediction, if I have to predict what kind of problems can occur, what kind of experience prediction can occur, what kind of production insights, real data checks, experience comparison. So this is where I will be focusing on these aspects. I would not be mixing certain things. Now, the final stage, the model output and post-deployment testing. This is where I have my post-deployment testing. I would be testing with the production data or production load data. So this is where I will be doing the end-to-end validation of my flows, regression testing to validate any impact on my functionality or stability of my model, and performance testing finally. And then the whole DevOps pipeline where the staging, UAT, and production deployment cycle happens, where I'll put this into a scheduled train, put all my business rules, and I would be doing all my automated environment check, data checks, and make sure that my report is giving me all those information. And this is where I will apply a lot of my RPA bots, which will give me the efficiency for automation here. From a model test automation standpoint, you can apply your existing frameworks for your data, web, and backend. For your API, you can consume the existing API automation frameworks which you have. For performance, you can use certain frameworks which you have. The idea here is that you are not going to tweak anything in the API or performance or data, web, or backend automation frameworks or tools which you use today. The idea is how you can actually combine them and complement them so that they can give you the benefit which you are looking at. These can be your hybrid automation frameworks which can support your mobile, web, desktop, RPA, and any model testing flows which you can integrate with your DevOps chain. You can have certain different type of touch points which you can build where you are having interaction between your systems and can have the health check and reporting features. Whatever API automation framework you have, this is in place because you have to provide feedback and check the quality of the interconnections between two parties. And you have to make sure that all those touch points between the systems are appropriate. From a performance standpoint, this is where you will meet the non-functional requirements and any SLAs your model needs to be met. This is where you have to support and tune certain models to make sure the efficiency is fast enough, because a lot of these models in real time are not offline, these are online. These are not performed as a batch. So your performance is critical here because they need to act in time to give the best possible options and predictions to the consumer before they even leave your screen. What we are trying to say here, when I combine these things together, you can have your frameworks in use for mobile, APIs, your Python, BTD frameworks, and you can have certain technical stack which you can combine. But overall, you can have your tools layer, utilities layer, your framework layer, and you can combine with some sort of integrated portals if you want to associate these frameworks, or you want to have certain test data portals, etc., wherein you can attach these, get the benefits, and have RPA bots to do certain type of task for you. From a model API standpoint, all of those tests which you do for your SOAP and REST services and make sure all the connections and then all the metrics from an API standpoint are in place. This is how you can perform. When I'm getting into a lot of performance testing of these models, you can have your framework which can be on-premise, on cloud. You can tie it with your continuous integration, run it the way you are doing, get your tuning recommendations, analysis based on the monitoring which you're doing for web application and database layers, and get the efficiency once you set up your load testing beds and give the production infrastructure controller and any load generation machines which you have in place. And this you have to tie with the DevOps pipeline so that you can get the best possible outcome. This whole chain can be integrated with your CI platform, so you can get all the benefits out of it. And a lot of this, again, as I'm saying, can be performed through bots once you train them. What we are seeing here in this particular case, by these intelligent methods, we have saved about 60% in terms of customer satisfaction, whatever testing you do in the AI model space, and whatever we performed using this logical grouping and certain methods and frameworks in place with the RPA and AI/ML modeling in place, we were able to get a higher satisfaction rate, and which means that 40% of the activities where you had humans which were performing those activities can now be automated, and the data science activities in testing can only be 60% done by humans. Rest 40% you can leverage your RPA and AI models to do that job. So this is a significant amount of saving. About 25% of improvement in your effectiveness, because your focus is now on the big ticket items and areas where it needs attention and intelligence of a human, but otherwise rest all the monotonous and operational tasks, you are moving into the bucket of automation. We also saw that 21% faster test cycle, because a lot of these test cycles, we moved on to the pods, which keep on running 24/7. A lot of these DevOps automation, we moved on to the DevOps chatbots, which can take instruction from us, and they can perform by setting up the environment, setting up the data required for your test cases, all the refreshes required, all the Jira board setup, your wiki board setup, all of those things we just passed on to your RPA bots, which gave us that faster test cycle. And it doesn't make sense that somebody is doing that monotonous and repetitive job, which can be passed on to a script or a robot. And what we have also seen is there are certain limitations when we work from human to human. There are time factors, there are dependencies, there are applications which are broken, and there are system dependencies, environmental dependencies, physical dependencies, which once eliminated and bots are in place, a lot of this gives you the edge and the accuracy which is required in an operation where data is sensitive and a time sensitive equation is there. So overall, the productivity improvement, what we got is beyond 15%. I'm quoting a conservative number here, but again, this is something which is a little debatable, which can vary from one organization to another and the project needs. What worked best for us is for a large telco. It could be different for you, but I'm sure that it's going to give you a good advantage over your regular operations and how you can perform. And this will help you in a lot of intelligence into your AI model for heterogeneous models which you are testing in the data science space. I'm happy to take some questions here. All right, I already have 3 questions in place. So first question says, isn't it what MLOps processes we define end-to-end process and tooling to test ML models? Yes, you're correct. This is MLOps process where we define the end-to-end processes and tooling to test ML models. But it also signifies what I'm trying to do here is I'm trying to divide this into logical buckets. What I've seen from my experience is a lot of these data science testing which you perform, people just get lost into it. They don't know where to stop. What is the complexity which they need to deal with? What are the areas which they need to test? People are just going and testing algorithms and whatnot in this industry. So by dividing these logical groupings, by telling exactly what you need to perform, what are the functions at each layer, where you need to start, where you need to stop, what are the operations which you need to move on to the robots, what are the operation things which you don't need to do, which you can pass on to the automation frameworks or tools, that can give you that edge. So that is what we are complementing it. But yes, this is the process itself stands as MLOps. The second question I have on my screen is, how do you handle lineage requirements and how do you version ML data models? What happens is when we work on the first set of requirements coming from marketing or business, when we train our data and perform. So our focus is on solving that particular problem at the first hand. We look at that problem, we try to solve it and put together into a staging box. This is where we perform most of our calculations and testing. We have 2 situations which we have in hand at that time. Because the model is new, in certain cases, if it's a new situation, new model, new business condition, you don't have enough data to test it. Second situation is you have historical data which can be consumed, but that data is historical and that is the problem which you're trying to solve. So you have to generate certain data as well. So the first part we solve is by generating the data into the required format for that particular model and test it. The second is we look at that historical data, what is the basis of that model, and test it. The third is when it goes to production, we monitor that model for certain time duration. Let's say we put that a model in production, we monitored that model for a month. We generated a month data and we looked at what are the outcomes of that model. This is what we call as feedback loop. This is where we take the feedback from the model users and then we compare it with my model. And this is where I find discrepancies, and this is where it goes back to my requirements. and I tie it to generate a new version of a model, which will fix those inefficiencies. And this is how I version my data model. This is the next version of my enhanced data AI model. The third question I have on my screen is, can you give an example for this you have done? Which models were tested and what was the use case? Okay. So one of the use case which we attempted was the call drop situation, wherein a consumer was moving from location A to location B. And this is a telecom use case in which a lot of frequent call drops were happening. And this is where our model was looking at the situations and figuring out where the call drops were happening and what is the root cause for that. And we were trying to fix those problems in real time. All right, so this is it. I do not have any more questions. It was a pleasure to have you here today. And thank you so much for your time.